Welcome back. This is the last topic of our course, groundwater. Now, groundwater is extremely important for humankind. Okay. And if we define the groundwater, it is defined as all the water in the ground occupying the pore spaces within the bedrock and regolith. Regolith is the soil. Okay. And around less than 1% of the water on the earth is groundwater. However, if we take in terms of the volume of groundwater, okay, or the fresh water, 40% times larger than the volume of all waters is the groundwater, like which is as compared to the fresh water in lakes and flowing through the streams. Most groundwater originates as rainfall. So, this is just the brief explanation about the groundwater, and this is what we were talking about the regolith. Regolith is a loosely unconsolidated sediments covering the earth's surface is termed as regolith. So, in this discuss about the porosity and permeability of the material, which is extremely important for holding the water, and we will talk about different type of aquifers, what are aquiclude, aquitard, and few rock types which are responsible for contamination, as well as few earth's material which is helpful in purification of the contaminated groundwater. Let us move ahead. So, if we take in terms of the water table first, what exactly is the water table we are looking at? Okay. So, water table, if we take the section here, okay, then we have we can divide this whole section into the area which is having close to the earth's surface. We will have very moist soil, and then we have the zone of aeration, and zone of aeration is comprised of loose material with open voids. It does not contain the water in it between that. Okay. And then we have a saturated zone, which will where the pore spaces will be occupied by the water. Okay. And the contact between the saturated and the aeration zone is the water table, and this water table will keep on fluctuating. So, sometime in during the heavy rain and all that, if the percolation or the recharge is good, then you may have the water table which is going up. Okay. It may go up. That means it will occupy the space in the zone of aeration, and that what we call is the fluctuation in the groundwater table, and usually it has been seen after the heavy rains. Okay. So, in wet season you will have the water table reaching right up to the in the zone of aeration, whereas the normal in dry season it will remain below, okay, and which remains always saturated. Nevertheless, if we keep on extracting water or pumping water more compared to the recharge happening in the area, you may experience lowering of a groundwater table. So, the zone of aeration, also termed as unsaturated zone, is a layer of moist soil followed by a zone in which open spaces in regolith or bedrock are filled mainly with air. Then we have beneath that, beneath the unsaturated zone is the saturated zone, a zone in which all openings, that is the pore space, are filled with water. And the upper surface of the saturated zone is termed as water table. So, this is what we were discussing in the previous slide. Now, movement of groundwater. Groundwater movement is a part of hydrological cycle. So, you have precipitation or rain, and then it will percolate down below the surface and finally reaches to the drainage or the stream which is flowing. Okay. The rainwater seep into the ground, it enters the groundwater reservoir, which is the zone of saturation. Around recharge and discharge of groundwater, this is an important part which usually we look at. If we are not having enough rain, then we may face lowering of groundwater. The time water takes to move through the ground from a recharge area to the nearest discharge area, okay, depends on the rate of movement and on the travel distance. Okay. How far the discharge area is located, and it depends on the time will depend on the travel distance, okay, between that two. So, you have to see that how much is the distance, and based on that it will take time. Okay. So, movement may take from a few days to possibly thousands of years in case where the water moves through the deeper part of the groundwater bodies. Okay. And this has been experienced in many places, and probably the Himalayan water or the water which got percolated in the Himalayan zone or the Indo-Gangetic plain might take thousands of years to reach the ocean. Okay. And this is what it explains, okay, that if you are having the shallower path, days, it may take years. As you move further deeper, it may take millions of years to reach this one. Okay. So, this is the relation between the recharge and discharge areas. Further, as I talked about, that porosity and permeability is extremely important. So, porosity, if we define, is the percentage of total volume of a body of regolith that consists of open spaces called pores, and porosity can be measured if you have the total volume and the volume of pores. Okay. So, volume of pores by total volume will give you the porosity. Now, well sorted sediments, porosity is about 30%, poorly sorted sediments about 15%, cemented sediments will about 8%. Okay. So, this is how it looks like. So, you are having well sorted material, then you will have higher porosity. If you are having poorly sorted materials, you are having larger grains and then smaller grains and all that, and then smaller spaces are available here. So, blue portion is showing the space occupying the by the water, occupied by water, and then cemented one will have the porosity of around 10%. Okay. So, you can refer to the different type of rocks we studied in the previous course, mainly the sedimentary rocks, metamorphic rocks and all that, okay, which will help you in understanding the porosity and permeability part. Further, if we look at the rocks, then vesicular and fractured basalts, that is the igneous rocks, will have comparatively higher porosity, around 30 to 40%. The limestones will have around 30%, because it has an capability of getting dissolved, or it will be affected by the dissolution activity. So, you will have a lot of huge cavities which will be available. So, it will have comparatively higher porosity. Then intergranular space, if you are having in the rocks, for example, sandstone will have little less because it will be cemented, and but you are having conglomerate, then you will be having little bit higher porosity. And then fractured granite will have less, because fractured granites are the massive rocks. Okay. So, This is the one of the important parameter which one should consider when talking about the groundwater. Then coming to the porosity and permeability further, the porosity of a sedimentary rock is affected by several factors. One is the size and shape of the rock particles or the grain size, okay, or the shape of the grain, the compactness of their arrangement, the weight of any overlying rock or sediments, okay, because that may also result into compactness. Then the extent to which the pores become filled with the cement that holds the particle together. Okay. So, the porosity of igneous rocks and metamorphic rocks are generally low. Permeability is a measure of how easy a solid allows fluid to pass through it. Okay. A high porosity does not necessarily mean a corresponding high permeability. Okay. So, for example, in case of the clay, okay, it has high porosity, but it has low permeability, okay. And this is because the clay particles have diameter of less than 4 microns. Okay. So, the particle size, that is the clay may have very high porosity because the percentage of pore space is high, okay, but the permeability is quite low here. Okay. It will not allow or permit the water to flow through easily, okay, because the pores are very small in size. So, though it has high porosity, it will have low permeability. Okay. So, this you can compare with the other sedimentary rocks, like you are having sandstone, or in case of the loose material, if you are having sandy unit, then it will have high porosity and permeability. But in terms of the clay, even though it has high porosity, it has low permeability because it has a low pores size. Okay. Further, as the diameter of the pore increases, permeability will also increase. Okay. So, for example, gravel with very large pore is more permeable than sand and can yield large volume of water to wells. Okay. So, groundwater bodies, if we take, we have what we term as an aquifer. It is highly porous, or we can say with high porosity and high permeability. Okay. For example, sandstones. And unconfined aquifers are not bounded by aquiclude. What are aquicludes? We will talk very quickly. Okay. Confined, bounded by aquicludes. Okay. So, aquicludes are high porosity with and low permeability. For example, shale or clay bed. So, you will have clay beds are high with high porosity and low permeability. Okay. So, those layers or the units are termed as aquicludes. So, if you have the unconfined aquicludes, okay, will not be bounded by any, or unconfined aquifers will not be bounded by any aquiclude areas, okay, whereas the confined one will be bounded by aquicludes. So, you have the layer with high porosity, but will not allow the water to percolate down or flow through. Okay. So, this is an example of that. So, you are having this is an aquifer with a blue portion, and this lighter ones are the aquicludes. Okay. And so, when you drill a well to pump out the fresh water, then you come across the confined, the top layer, and then you come and puncture this aquifer. If you drill further, sometime you lose the aquifer. Okay. and in some places even the fault plays an important role. This we have studied in geological structures and all that. So, faults plays an even important role or significant role in generating artesian wells, where because of the gradient which the aquifer is acquiring, because of the topography, this will result into the natural pumping up of the water on the ground. Those are the artesian wells. And aquitard are between aquifer and aquiclude. So, example, if you are having silt or silty clay layers or the units, they are termed as aquitard. Aquifluge or aquifluge is low porosity and low permeability. For example, granites or limestones are the examples of aquifluge. Now, another important aspect of groundwater which are seen, that if you keep on having excess removal of water, then you will experience that the depth of the groundwater increases, but it increases close to the areas where you are pumping out the excess water. So, sometime you may observe that you have to lower down your well, or if you are having the submersible pump, you may have to go deeper, and that happens because you develop a cone of depression. The surrounding areas you may not have the change in the water table, but at the place where you are pumping out excess water, you may develop the cone of depression. So, a well will supply water if it intersects the water table. When water is pumped from a new well, the rate of withdrawal initially exceeds the rate of local groundwater flow. So, if it exceeds the local groundwater flow, because this is the flow, there is the gradient here, that will result into imbalance in the flow rates, creates a conical depression in the water table immediately surrounding the well through which you are pumping out the water, and that is termed as cone of depression. Now, springs are most of the areas you will find the springs are again a very natural phenomena, and a spring is a flow of groundwater emerging naturally at the ground surface. And small springs are found in all kinds of rocks, but almost all large springs issues from lava flow, the areas which are having lava flows, limestone and gravels. So, if you go in Himalayas, you will find that the areas which are having the limestone as well as the gravelly deposits will have lot many springs which are supplying groundwater to the areas. A perch water table, what is that? The perch water table will be the water body which is sitting above the normal water table, and that happens because it has some base which we were talking about, the aquiclude, which may result into the formation of the water body here. So, an impermeable layer of clay sediments in the zone of aeration. So, as we were talking about the zone of aeration, and then we are having zone of saturation, and then in between, the contact between that is your zone of, or that is a water table. But perch water table you will find much above the normal water table. So, you may be happy that you got the water, fresh water at very shallow depth, but that may not last for longer period. Okay. You may this body may dry out very fast if the recharge is not so much. Okay. So, perch water table, a impermeable layer of clay sediments in the zone of aeration may produce a perch water body. Okay. A water body which is suspended at the top of an aquiclude that lies above the main water table. So, this is sitting above the main water table. This is your water table here, this one, and it is sitting above the main water table. So, actually you should have got the water when you encounter the zone of saturation, okay. But you can, and few locations you may come across at very shallow depth. But such water table or perch water body will not yield water for longer period. So, water quality and groundwater contamination, this is another important aspect. Okay. So, the chemistry of groundwater shows that the compounds dissolved in groundwater are mainly chlorides, sulfides, bicarbonates of calcium, magnesium, sodium, potassium and iron, and this all can be yielded from the rocks. Okay. So, the composition of groundwater varies from place to place according to the kind of rock in which the water occurs. Okay. For instance, water rich in calcium and magnesium bicarbonate dissolved from local carbonate rich rock, okay, and which is termed as hard water. Whereas, if the bedrock is volcanic in nature, or you take sandstone, little dissolved matter and no appreciable calcium is found in the groundwater, which we call as a soft water. So, this is what we call the potable water. Okay. So, water circulating through sulfur rich rocks may contain dissolved hydrogen sulfide that has an odor of rotten eggs. Okay. So, this is nothing to do with the contamination by something else, but it can be resulted from the rocks which are rich in sulfur. The most common source of water pollution in wells and springs is sewage, drainage from septic tanks, waste disposal, etc. So, this is also another bothering which contaminates the groundwater. Okay. For example, this one. So, if you are having a septic tank here, and then though it is the well is away, you are not allowing the pollutants to get cleaned. Okay. So, it will percolate down. So, you are having the unsaturated zone, you are having saturated zone. So, and you are pumping out the pollutants which are coming in this area. Okay. Whereas, if you are having the septic tank and the well is located far away, then you may have the well which will produce pure water, because you allow the contaminated or contamination to get purified. Okay. So, you are not having much of that. Apart from that, it is also important that what is the type of material in which you are having the water table, okay, or water body. So, sand is one of the best which acts as an purifier, okay, whereas here we are having coarser sand with gravels. Okay. So, it will not clean or purify the water as compared to what we see in the sandy aquifer. So, if the sewage contaminated with bacteria passes through sediments or rocks with large pore spaces, okay, such as coarse gravel or limestone, which will have like cavities, okay, it remains polluted. So, here if you compare the coarser gravel or the coarse sandy gravel, it has large pore space as compared to what we see in the sand. Okay. So, this will remain polluted. Okay. If the contaminated water percolates through sand or permeable sandstone, it becomes purified within short distance. Okay. So, sand promotes purification. So, excess pumping, another one, contamination of the groundwater close to the ocean. If you keep on pumping the fresh water, then you are inviting the saline water to intrude into the aquifer. Okay. And this is because the density of the fresh water is about 1 kilogram per liter and the saline water is bit heavier. So, this will contaminate your aquifer, and this phenomena we say the intrusion of saline water or sea water into the fresh aquifer in the coastal areas. Now, toxic waste and agricultural poisons, vast quantity of human and industrial waste are deposited each year in open basin, okay, or excavated at the land surface. So, without having understanding that what type of material is sitting below, okay, we keep on dumping the toxic waste, okay, and that can contaminate the groundwater. So, when rainwater seeps down through the site, it carries away harmful soluble substances, and that will result into the contamination of groundwater. So, this is an example that if you, this is an open dumping place. Okay. So, of course, we say that it is away from our houses and is away from the factory, but it will keep on contaminating your water. Okay. So, it is always advisable that to pump the waste down deep below, where you are not having any chance of putting your wells close to that actually. Or you can do the another advantage which you can take is that you lined up the landfill, okay, so that you doesn't allow this the toxic material to seep down into the aquifer. So, this will create problems, and if you adopt this one, this will help you in having pure water. Okay. Pesticides and herbicides are sprayed over agricultural fields and suburban gardens to help improving quality of productivity. Okay. Some of these chemicals have been linked with cancer and birth defects in humans, and some have led to disastrous pollution, declining the wild animals also. Underground storage of hazardous waste, again we need to have understanding of the landscape and the subsurface geology. So, most studies concerning disposal of hazardous waste, both toxic and radioactive, have concluded that underground storage is appropriate provided safe sites can be found. Okay. So, safe sites for disposing the radioactive waste must not be affected chemically by groundwater, one. So, that you can do by injecting at the deeper part. Second, physically by earthquake. Okay. So, they are not also affected physically by earthquake. Okay. So, the deeper portion will not have any effect on that. Okay. Or disruptive events or accidentally by people. Okay. So, you cannot have the place where you dig and you open up the waste disposal pond. Okay. So, you may have to locate such an area which is not affected chemically by the groundwater. Okay. So, if you put deeper things at the deeper level, then you may save yourselves from contamination. Of course, other part is that you should not also have the fault lines close to that, which may rupture the waste disposal areas. Okay. So, geologists generally agrees that the ideal underground storage sites for radioactive waste should possess the following characteristics. Okay. The enclosing rocks should have few fractures and low permeability. The enclosing rock should have no present or future economic mineral potential, because maybe after 100 years or 50 years you may come across that no, you need to have some mineral exploration, and you start digging and you will expose the waste disposal areas. Okay. So, that should not be, the area should not have any future mineral exploration. Local groundwater flow should be away from plants and animal life. Okay. Only very long path of groundwater flow should be directed towards the places accessible to humans. Okay. So, that it get eventually purified until it reaches the groundwater where human settlements are there. Okay. So, the area should have low rainfall, the zone of aeration should be thick, the rate of erosion should be very low, the probability of earthquake or volcanic activity should also be very low in that area. Future climate change should be unlikely to affect the groundwater condition substantially. Geological activities of groundwater, if you take, then what you have is that these are the mainly the limestone which have the capability of having cavities will act as in the areas which will result into more contamination. Okay. So, for all rocks in the earth crust, the carbonate rocks are amongst the most readily attacked by dissolution activity. So, such rocks or the areas comprised by such rocks should be avoided for selecting the sites for the disposal. So, I will end here. Thank you so much and best luck for your exams. Okay.